Hi students, so welcome back. We were studying current electricity. So in current electricity, in the first lecture we have seen about charge, current flow. Then in the next lecture we have seen about drift velocity. Then drift velocity and its relation with the current, the reason for drift velocity. Then about thermal velocity. Okay, all these stuffs we have seen. So today we are going to see about electrical resistance. So what is electrical resistance? What all factors makes this electrical resistance? So all these things we will see today. So this is nothing but obstruction to the flow of current. Obstruction to the flow of current. General word meaning resistance is nothing but obstruction. So electrical resistance is nothing but obstruction to the flow of current. Obstruction to the flow of current. So why this electrical resistance happens? So in the previous lectures we have seen a conductor. When we connect this conductor to a battery, electric field will be produced. This electric field drives electrons to move. In the presence of electric field, charged particles will experience a force. We have studied that in electrostatics. So this will start moving. So if electric field is in this direction, if this is electron, negatively charged particle, this will be experience force in this direction, this will be moving. So as a result, current will be moving in this direction. So this will be the direction of current. So when these electrons are moving, it will have to encounter with a lot of kernels. What are kernels? Ions, or the vacancy of electrons, right? From an atom, if electrons move out, this will become an ion, or we call them kernel also. So this electron, if this is a kernel, this electron will collide with this, then again it will collide with another particle. So likewise there will be lot of collisions in the path. So as a result there will be resistance. So all these collisions are the reason for what? For this electrical resistance. That is the reason. Now we will see unit of resistance is what? R is equal to V by I. So in this way we can say this is volt per ampere, and this unit is nothing but ohm. Okay, we represent it like this. Okay, now when V is proportional to I, so how much potential difference we are giving, that much current flow will be there. So current is nothing but a rate of flow of charge. See, just imagine we can take the analogy of water flow in current flow. Suppose if the altitude of waterfall is very high, then the water flow will be that much stronger. So higher altitude to lower altitude, that is the condition for water flow. If it is in the same altitude, the flow won't be there. Movement will be there, but flow won't be there. So if it is from higher altitude to lower altitude, water flow will be there. So that is what we call water current. In this case, not higher altitude, but it is higher voltage to lower voltage. So if there is potential difference, current flow will be there. So when we say this V is not just voltage, it is voltage difference or potential difference. So V is proportional to I. We can say when we equate, we put a proportionality constant. This is what is resistance. Okay, this is what is resistance. So that proportionality constant, we take it as resistance. Variable resistance is also there, but let us confine our discussion to this for now. In the previous class, we have seen the formula for drift velocity is E divided by m into tau. E is charge, capital E electric field, mass of the charged particle or charge carriers, and tau is the average relaxation time. Average relaxation time is the time between two collisions. So lot of electrons, lot of collisions, so all these things putting together, we take average relaxation time. Now the relation between drift velocity and current, NEA VD, if you want, you can write in this way also. I is equal to VE NA. Just if this is easy for you to remember, you can say, we say na Tamil Vena, same way you can remember this in that way, Vena, VDENA. Okay, the relation between current and drift velocity. Substituting this here, I is equal to NEA EE divided by m into tau, and this electric field E is equal to voltage difference divided by L. So may substitute that NEA E V divided by m is already there. I put L, then tau. So rearranging this, I is equal to NE square tau, then A V divided by m into L. So from this, and V is equal to IR, V is equal to I into R. So just replacing like this, V is equal to ML divided by NE square tau into A into I. Okay, so from this we can take R is equal to ML divided by NE square tau into A. This is the most fundamental formula for resistance. We have studied rho L by A in the lower classes, that I agree, but this is the most fundamental formula for resistance. Okay, R is equal to M, mass of the charge carrier, L, length of the conductor. What is small n? Number of charge per unit volume, or we call them number density. E is the charge of the charge carrier, tau is the average relaxation time, A is the area of cross section. Okay, pause the screen, note it down. So R is equal to ML by NE square tau into A. Okay, so this is the formula for resistance. Now this resistance here, resistance of steel or resistance of copper, when we consider resistance of a particular material, if we consider, Can I say all steel will have same length, or can I say all the steel rods will have same area of cross section? No, never, senseless. So this will vary, this will vary. Now just think, mass of a charge carrier in steel, that will be constant, right? Number of charge carriers or number of electrons per unit volume in steel will be constant, and charge of electron is constant. Average relaxation time in a material is also constant. So taking this part, m by n e square tau is equal to constant for a particular material. This is constant for a particular material. M by n e square tau is constant for a particular material. So this constant we named as resistivity. So resistivity is m by n e square tau. Resistivity. So resistance becomes rho L divided by A, where resistivity is the property of a material. So resistivity is constant for a particular material. Resistivity for copper will be 1, resistivity for gold will be another 1, resistivity for steel is another 1. So this is what is resistivity. This is constant for a material, and resistance will vary according to change in material, change in length, change in area. This resistivity, one first factor is depends on material. Second, resistivity depends on temperature. Okay, this depends on the material and the temperature. If we increase the temperature or decrease the temperature, then resistivity varies. This will come in the next topic. Okay, then R is equal to rho L by A. So rho is equal to RA by L. So unit is nothing but ohm meter square by meter. So this meter, this will be cancelled out. So unit of resistivity is ohm meter. Ohm meter. Okay. We will do a question. A wire of length L has resistance R and wire is stretched to twice its original length. Find the new resistance. So if this is a wire, now I am stretching it and increasing its length. So what happens if I increase the length to double? If this is L and this is 2L, if its area of cross section is A, its area of cross section will be different. Okay, when we stretch something, definitely its area is going to get reduced. So that we will have to consider here. So resistance of this wire R is equal to rho L by A. The resistance of new wire is going to be R is equal to rho into 2, because it is twice its original length, divided by A dash. Need not come to a conclusion. Just like length is increased, area is double or half, just we will verify. Definitely, even if I stretch or even if I compress, definitely volume will be same, volume will be constant. So A into L, of this wire, volume will be equal to area of this one, A dash into 2L. This will be same. So what we will do, A dash is going to be L will be cancelled off, 2 will come this side, A by 2. So R dash is going to be rho into 2L divided by A by 2. So this 2 will go up, and what we are going to get is R dash is equal to rho L by A into 4. This is going to be 4R. So option C is the correct answer. So suppose if L is the given length, if length becomes 2L, then volume will be constant. Volume is constant. So A into L will be A dash into L by 2. We will be getting A dash is equal to A by, if this is double, L is 2L. So 2L, A dash is equal to A by 2, and we will be getting R dash is equal to rho into 2L divided by A by 2. So rho L by A, 2 goes up, this into 4, we will be getting 4R. Suppose L is the given length, this is going to be 3L, volume is constant, A into L is going to be A dash into 3L. So we will be getting A dash is equal to A by 3. So R dash is equal to rho into 3L divided by A by 3 is equal to what? Rho L by A. This 3 goes up and we will be getting into 9, we will be getting 9R. So this is nothing, 2 square into R, this is equal to 3 square into R. So from this we can conclude, if length is made n times, then resistance will become n square times. Associatively it reduced, right? When length is increased, definitely resistance will increase. So when length is increased, area will be decreasing. Resistance and area are inversely proportional, so the reduction in area also will affect there. So if L dash is equal to NL, then just simply we can take R dash is equal to N square into R. So remember this shortcut or this relation and directly smash without wasting your time. Okay, we will do another question. A wire of resistance R is compressed to half of its original length. Find its new resistance. Okay, so length is reduced to half. So L dash is equal to what? L by 2. L dash is equal to L by 2. So here what is N? N is nothing but 1 by 2. According to the relation, R dash is equal to what? N square into R. Directly put N here, 1 by 4 into R. So answer is going to be option D, R by 4. So if length is made 10 times, what will happen to resistance? What will be the new resistance? R dash is going to be N square into R, 10 times into R, this is going to be 100 R. So likewise we can directly put the things. Okay, now suppose if they change the question, find its new resistivity. Find its new resistivity. We will change the options. Okay, what will make 2 row by 2 compressed, right? Okay, row by 4 will make it this one 4. Okay, right. So what will happen to resistivity? Think for a while, answer yourself, verify the answer here. Pause the screen, think. So what is the answer you are getting? Answer is B. So some of you might have got 4 row or row by 4 also. Thing is, R is equal to rho L by A. So if you take rho is equal to RA by L. So R into, if you put L by 2 here, area will become what? A dash into A into L is equal to A dash into L by 2. So A dash is going to be, L will be cancelled, 2 will come here, 2A. So if you put 2A here, you will be getting RA by L into 4. So if you get this answer, this is wrong using this relation. So resistivity is the property of a material. Resistivity depends on, first thing is temperature, another thing is material. Material means what kind of material, not its dimension. Very clear, please understand this very clearly. This question they have asked in previous exams like AIPMT, medical itself, not Neet. Before Neet comes, it was AIPMT and all India pre-medical and PMT, those were the names. So again, same entrance exam only, but they asked this question, same question. So resistivity is not going to change by changing the dimension of a material. Resistivity changes only with the material or temperature. Okay, please make it clear. So our class purely concentrates on resistance today. So just see, we will analyze this formula once again. Rho L by A. So resistance R is equal to rho L by A. So this L is length of the conductor, A is area of the conductor, cross section area of the conductor, resistance rho L by A. So based on this, we will do a problem. Okay, see, look here, this is a conductor, this is a conductor. So current is passing through the conductor, area of cross section is here, this is area is given as A. Okay, so now here, what is the resistance? So if your answer is R is equal to rho L divided by A, rho L divided by A, then this is wrong. Real answer is R is equal to rho, this length is given as A, so rho A divided by this area A. So what I am trying to, where I am trying to drag your attention is, when we say R is equal to rho L by A, when we say R is equal to rho L by A, this length is the length of the conductor along the flow of current. When we say R is equal to rho L by A, that length is nothing but along the flow of current. Length is to be taken along the flow of current. Say for example, in the same figure, if the current is flowing like this, if we take this as B and this as C, then okay, if this is first phase, okay, if this is a 3D slab, iron slab or something like that, if the current is flowing like this, this is 1, this is 2. So along first plane and second plane, then R1 to 2, this I can say rho A divided by BC. What is this BC? Area of this area, or this cross sectional area is what? BC. Rho A, length of the conductor is this, current is flowing in this direction, so this length I will have to consider. So this is one possibility. Another possibility, suppose if the current is moving like this and it is going up, then how? What is the resistance? Pause the screen, think for a while, write for yourself. R is equal to rho. Here what is the length? Length is actually C. This thickness. Current is flowing in this direction. So this thickness we will have to take as length. So rho C by AB. So which area of cross section you will have to take? This time we will have to take this area. Okay, this area. So this is the second possibility. Now what else is there? Suppose current is flowing like this. Okay, just like this. If this is the slab, then current is flowing like this. See, first thing is, this is the length A. This is area BC. So current was flowing like this. So I took rho into A. This is A. Rho A. This is B. This is C. So rho A by BC I have taken. Now current is flowing like this. Okay, from downward direction upward. Okay, from bottom to top. So that time I have taken the length as C. This thickness I have taken. So rho C by, this is the area of cross section this time. Okay, so AB. Now this time we have taken like it is coming like this, or it is coming from my side and current is coming to you. So this thickness is the length of the conductor here. So third case, R is equal to rho. What is this thickness? B divided by AC. So which is the area of cross section now? The area of cross section here is this one. This is the area of cross section now. Okay, clear. So it is going like this, coming out like that. So from this question, the concept is very clear, I hope. This concept, I mean rho L by A. What is that length L? Okay, from this question, this L is very significant. They can give L on some other side and they can fool you or trick you just by giving length on some other direction. We will be writing R is equal to rho L by A. Very easy question. Mark it, will come out. But that will fetch you a negative mark. So please be very careful about the concepts. Okay, clear? Note it down. So here this is another question. Look at the figure. Length of the conductor is given. And resistivity is rho. And this is a hollow tunnel inside this conductor. So current is flowing in this direction. Okay, current is flowing in this direction. So this is hollow inside, and outerwards there is some material, conducting material. Current is flowing like this. What is the resistance? That is the question. So pause the screen, think for yourself, do it, verify the answer. Okay. So basic formula of resistance R is equal to rho L divided by A. So this is the length of the conductor. No problem here. It is very clear. Current is flowing in this direction. So this length can be taken. So rho L, that is fine. What about area? This is a circular conductor and current is flowing like this. So what is the area? Current is flowing in this area. So total area of the conductor is, suppose if this is resistance R, then that is pi R square. but through how much area current is passing, only that we need to consider. So how much is that area? So total area is R2 pi R2 square. This is the total area. Just subtract the inner hollow area R1 square. So we need only that area where current is flowing. So pi R2 square is the total area. From that we need to reduce this hollow part. So here resistance is nothing but rho L divided by pi into R2 square minus R1 square. So which is the correct choice? Option C is the correct answer. Okay, let us do another question. It is like a conductor. So length of the conductor is L, and okay, let us take this radius R1, this radius R2, and its resistivity is rho. So you know very well about the importance of direction of current. So in which direction current is flowing, that length we will have to take, and the corresponding area of cross section. If this is a conductor, if current is flowing in this direction, okay, then we will take this area of cross section. Suppose if the current is flowing in this direction, then which is the area of cross section? See, this area of cross section is varying. This area of cross section is varying. When it is moving like this, area of cross section is varying. So here in this question, current is flowing in this direction. In this direction, in the sense outwards. Just like how to say, like this. Current is flowing outwards. So how to do that? That is not our headache. Like how to connect the battery like that, any method can be used. So that is not our headache. They have given in the question, if the conductor is this hollow, okay, inside, and current is flowing in this direction, that is the only data given. Now how to find the resistance of this? Okay, this is the question. Okay, so these kind of questions in CBSE level, then if we have done some questions, Neet kind of questions, and we have done little before a JEE kind of question. This is also important if we think in the advanced level. So one or two questions of that type if we do, then it is better for us to improve our thinking ability, or if we do tough questions, then moderate questions or easy questions will become much easier. So always you can do this. We will make it easy. So how to do this question? So here, see dear students, suppose if we take a paper like this, okay, suppose if this is the conductor, suppose if this is the area of cross section of this conductor, the current is flowing in this direction. So here the area is smaller. When we take like this, area is bigger. So in the last extreme, area is much higher value of area we get. So area is changing. We need to take all this area also. So the only way to do this question is by integrating, summing up this area of this is kind of cylinder, right? So this cylinder, we will take small cylinders like this. If this is a cylinder, just I will take a new figure and we will solve this question. So if this is the inner diameter and if this is the outer diameter, we will cut a small strip of cylinder from this. We will cut a small strip of cylinder from here. A small strip of cylinder like this. Just like this. Okay, we will strip. Then after finding the function for this, we will add from here to here so that we will get the full area. So this is not just a just a plain strip. This is actually a cylinder. So when you take this cylinder, it will appear in this way. Appear in this way. This will be a strip of cylinder. Just like this, a strip of cylinder. A strip, this is the area of cross section of this strip, just like this. This is the strip. Three-dimensional view you can imagine, just like this. So we will find the small resistance that is present in this strip. Then we will add all the resistance of this one, entire circle. So how to find? So how current is moving? Current is moving in this direction. So suppose if from the center, if this strip is at a distance r and the width of this strip is very small dr. So what is the resistance of this small strip? We will take small resistance of this small cylindrical strip is nothing but general resistance, what? Rho L by A. If it is circular, we will take what? Pi r square. This is what? Area. So here what we will write? Think and tell me. So here one thing is clear. Rho is the resistivity. What is the length actually? We are taking this small strip. So rho dr. This is the length, correct? This is the length. Current is moving in this direction. So this much small strip we are taking. So its length is actually dr. Then what we will have to take? We will have to take this full area. This full area. Okay. So divide by full area is how much? This is the strip's perimeter. Full area means this much length also we will have to consider. So I can write 2 pi r into L. Whether you are able to digest this, think. Compare with this equation. 2 pi r is this strip's perimeter into this much is their perimeter into this length, full length. 2 pi r means this much we will get into this full length. That will be the area. So this is the small resistance of this strip. So now for full resistance, what we should do? R is equal to integral dr. From where to where? From where to where? Initial diagram, do you remember? It was like this. From where? It was like, I will draw. Its cross section was like this. This radius was R1 and this radius was R2. This was like this. So from where to where? Till R1 it is hollow. From R1 to R2. So R1 to R2. This is what? Okay. Now we will put it here and we will integrate from R1 to R2 rho dr by 2 pi r into L. If we integrate this, whatever answer we are getting, that is the final answer. Now I remove all these figures. Now we are continuing our integration to find this. So integral R1 to R2 rho dr divided by 2 pi r into L. So this is constant. So rho by 2 pi into L integral R1 to R2 1 by r dr. It is very clear now. This r is what? Changing, varying from where to where? From R1 to R2. So rho by 2 pi L. What is 1 by r? That is log r. Putting the limit R1 to R2. R1 to R2. So in rho by 2 pi L log R2 minus log R1. So resistance R is equal to rho by 2 pi L. I can put log to the base E R2 by R1. So this is the answer for that question. And if you have doubt in integration, just this is nothing but integral 1 by x dx. If we put a limit from 1 to 2, from 1 to 2 if we integrate, this is nothing but integration of 1 by x is log x. And we will have to substitute this upper limit and lower limit 1 to 2. So this is going to be log 2 minus log 1. Log 2 minus log 1 is log 2 by 1. See, integral x square dx. If it is from 1 to 2, what we do? X cube by 3. Putting the limit 1 to 2. I have given some integration examples in the first session of current electricity. So that mathematical concepts we are applying here and we are getting this answer. Okay. So dear students, this is what is resistance. Resistance is nothing but the obstruction to the flow of current. So here R is equal to rho L by A. Resistance depends on the resistivity, length of the conductor along the direction which current is flowing, and the area of cross section. Area of cross section in the direction which current is flowing. Current is flowing, then this will be the area of cross section. If current is flowing, this will be the area of cross section. And resistivity rho depends on the material and the temperature. So just the relation R is equal to rho L by A. There are inner concepts inside that. We have seen all that. We did some Neet kind of problems, JE level problems. Last question which we have discussed is just for JE advanced level. So whether even if you are preparing for Neet also, practice that problem, because it will be helpful for you to improve your mathematical skills is not necessary for Neet while for studying medicine. If you think like that, maths we are studying for improving our analysis skill or reasoning skills, because if we study these kind of problems, then the moderate kind of problems or tough questions you will feel easy, and there will be small application of integration and differentiation will come in physics. Okay, so practice that problem, and if you get similar problems also, it is okay if you practice it, so that you can improve your thinking ability and problem solving skills. Okay, thank you. We will see in the next class.